Okay, so find the sum of those numbers. Okay, so we want to add up those numbers. How do we do it? So notice right off the bat, there's not commas between those numbers. There's plus signs, and it even says find the sum. So we're not just trying to list them, we're trying to add them up. All right, well, how do we do that? Well, let me help you figure out. First thing we got to determine, so step number one, is this an arithmetic or geometric? Is this arithmetic or geometric? So let me go to the notes with you. So arithmetic, remember, arithmetic adds or subtracts the same number from term to term. It's arithmetic, like when you were a kid, you learned to add and subtract, first thing you ever learned in math. And then geometric, let me erase some of my previous scribbles here. Geometric, that it multiplies or divides the same number every time. So which one is this? Is this, whoa, I went way too far there. Is this arithmetic? I found my problem. There it is. Is this arithmetic or is it geometric? Well, mine, what's it doing every time? Well, it's adding 3, isn't it? It's clearly adding 3. So that means it's arithmetic. It's adding 3. If it was multiplying by the same number every time, it would be geometric. But if it's adding or subtracting the same number every time, that's just arithmetic. So it's just adding through every time. It's an arithmetic set of numbers. Okay, so what? Well, now here's where we're going to actually use this formula right here. Now, how do you know? I know that's a lot of the battle. You'll have these formulas with you on the exam. How will you know which one to use? Well, it says sum. that's the main thing, right? It says sum and it has S sub n instead of A sub n. And it's going to be the same deal when we get to the geometric examples. There's, see the geometric? There's an A sub n and a sum S sub n for geometric, just like there is for arithmetic. So that's how you know. You just, if it's a sum, you use the S sub n. So we're trying to find the sum. We're not just listing them. So we're going to use this formula. Now, or you can use this one. It works the same. I'm not going to bother that one. I'm just going to use this one right here. And so the S sub n is n over 2, A1 plus A, and it's the sum. I'm trying to find the sum. That's what keys me in. S sub n, not A sub n, because I want the sum now. I want to know what they add up to be, right? So let's do it. So I'm going to use, so step 2, pick the right formula. S sub n is n over 2, A1 plus AN. So the arithmetic S sub n formula. So by the way, so notice we have 4 formulas, right? That you got to pay attention. There's really just, I mean, the main ones are 4 formulas. We have, I mean, there's an extra one here and there's R, but you know, other than that, the main four, there's an A sub n and an S sub n for arithmetic, which is regular and sum for arithmetic. And then we have A sub n and S sub n for geometric, which is regular and sum for geometric. So that's how you want to think about it. You got 4 main formulas. A sub n, S sub n for arithmetic, A sub n, S sub n for geometric. Well, how do you know what to use? Well, you first figure out if it's arithmetic or geometric sequence like we did. Is it adding, subtracting the same number, or multiplying? Ours is adding 3, so it's arithmetic. And then do they want the sum or just regular? They want the sum. So they say sum, you use the S sub n arithmetic formula. Okay, so let's plug this stuff in. So how are we going to do it? Now the problem is right off the bat, we don't know n. I don't know n. N is how many terms? I don't know how many terms there are. Could I use the other formula? No, that has n also. It's not going to really help. Yeah. So all right. So let me help with this formula. We're gonna have to do some work either way. So this right here is the first term. This stands for last term, and n is the total number of terms. And I'll show you this down here in the formulas. A1 is the first term. AN is the nth term, in this case, the last term, and n is the number of terms. See, it is right there in the notes. Okay. So just being clear here, first term, last term, number of terms. Okay, so I know the first term, that's 5. I know the last term, that's 29, no problem there. What I don't know is the number of terms. How am I going to find out the number of terms? Well, we're going to have to do something else over here on the side. So to find n, what are you going to do? You're going to have to use the other formula. So I'm going to actually use both of the arithmetic formulas this time. I'm going to have to go back to this guy. I'm still doing arithmetic. I'm not going to do anything geometric. This is an arithmetic set of numbers. So I'm going to use this one right here. A sub n is a1 plus n minus 1d. A sub n is a1 plus n minus 1d. So I'm going to use it. Now, what's a sub n? Remember right here. What's a sub n? Last term. What's the last term? There it is. It's 29. What's a1? A1's the first term. This is a1 right here. This is an right here. That's 5. You good? Plus n minus 1 times d. What's d? D is 3. It's the difference from term to term. It's right here in the notes. D is the difference or the jump from term to term. So, all right. So I'm having to use two formulas. I'm having to go over here. This is hard work. To go over here on the side and first figure out n. I'm trying to find n, right? Find n. So I'm going to distribute. So I get 29 plus 5 plus 3n minus 3. 29. 5 minus 3 is 2. How do you finish solving there for n? Subtract 2 from both sides. And boom. And then we get what? 27 is 3n. Last step to get n, divided by 3. So n equals 9, doesn't it? 27 over 3, is 9. So n is 9. So what? So now bring that back, pop it in right there. And then here's a1, and here's an. Now, step 3, we can finish up. S sub n is n over 2. What's n? Well, now we know n is 9 over 2 times a1. Now we know what a1 is. It's 5 plus an, 29. There we go. Does that make sense what I've done? Now I just finish this up, which I will. But is that making sense there? So this is tricky. This is a more advanced problem. We had to use both formulas. So the first thing I had to do is I had to, well, here, I'm talking, I haven't finished the problem. Let me just finish up. S sub n is, divide this on your calculator, you get 4.5. Combine these guys, you'll get 34. Multiply 4.5 times 34 on your calculator, and you get 153. And that's the answer. And I'll recap about what happened. So 153. So in other words, all these numbers here add up to be 153. That's tricky. We just figured out how to add up a whole big group of numbers where we're not even seeing the whole list, and we know the sum without doing it item by item, which means this is powerful. We could do this for 1,000 numbers or 1,000,000 numbers using these formulas. So again, how did we do it? We first looked and said, all right, is this arithmetic or geometric, right? Arithmetic or geometric? Well, it was adding the same number every time. That makes it arithmetic. If it was multiplying, it'd be geometric. So then we use the arithmetic now, and with sum. So I started, the main attraction equation is the sum equation. We had, remember, there's an a sub n and s sub n here. In fact, here is the a sub n, and here is the s sub n. But I want the sum. I want the s sub n. S stands for sum. And so I wrote that out. I knew a1 and an, that's first term, last term automatically. But I didn't know n, which is the total number of terms. To find that, I came over here to find n, and I had to use the other arithmetic formula right here. And I put in the an, which is again the last term, and the a1, which is again the first term, and the d, which is the difference from term to term, the jump, 3. And then I was able to solve that for n, and then put that, then go back to the original form. Once I had n from this side formula, go back to the main formula, plug in your n is 9, plug in your a1 and your an, hit the buttons on your calculator, 153. And so there we go.